In this video, we're going to continue looking at how we work with sigma notation, but we're going to focus in on some tricks that can loosely be called changing the counter variable. Changing the counter is sometimes advantageous, particularly if the subscript of the term has got a funny look to it. So I want to actually start with a basic kind of an example. If we have a series that looks like the sum as k goes from 1 to 5 of ak plus 3. That's going to be a4 plus a5 plus a6 plus a7 plus a8. This particular term is when k is equal to 1, when k is equal to 2, when k is equal to 3, when k is equal to 4, when k is equal to 5. It is often advantageous to write this particular sum as a different with a different counter at a different starting place. Since my sum is starting at 4 and running through 8, a lot of people would rewrite this as the sum as, say, L goes from 4 to 8 of a sub L. Now, the formal substitution to go from this version of the sum to this version of the sum can be summed up as, if we let L be equal to k plus 3, then ak plus 3 is just al, and so we can then simply rewrite the sum as k goes from 1 to 5 of ak plus 3 as being the sum of the ALs as L goes from 1 plus 3 to 5 plus 3, because what we're basically doing is we're putting in the starting and ending value for k into this formula to find out the starting and ending value for L. And of course, when we do the little bit of arithmetic, we see that we've got L runs from 4 to 8 of the a sub L's. This kind of a trick is actually fairly important, and I want to kind of make a general idea of how this is going to work. So we actually have a more general pattern that I want to introduce you to. If I have a sum as k goes from a starting value to an ending value of ak plus some kind of a constant, I can always pull the same kind of change of counter variable. I can let L be equal to k plus c. It's typically this particular thing right here. And then what I want to do is I want to rewrite the sum so the term will become an AL, but I also have to rewrite the starting and ending values. And so when k is equal to the starting value, L is going to be that starting value plus c. So this sum is going to run from as L. Let me clean up my notation. As L goes from start plus C up to, well, when k is at that ending value, L will be the ending value plus C, so I will get the end plus c up here. And so there's always a way of rechanging things. And I do want to look at a specific example of this. So as an example, suppose my first series is written as k goes from something like minus 3 up to 5, and I'm just going to say ak, and I really want to make this equal to, well, let's actually say ak plus 1. And I want to get rid of this complicated stuff here. I want to deal with not a k plus 1, but I want to rewrite this as AL, and L going from somewhere to somewhere. Well, let's see. I'm going to have L is equal to k plus 1 from this part of the notation, but then I also have to convert the beginning and ending of the summation. When k is equal to minus 3, L is going to be equal to minus 2. And when k is equal to 5, L is going to be 6. So my new sum would be L goes from -2 to 6. Now, the other time when we want to rechange the counter is when we want to make the counter start at a particular value. So let's look at that idea as well. So starting the counter at a desired place. And the usual desired place is to start the counter at either 0 or 1. So again, I want to start this out with an example. So let's say I have a sum as k goes from, let's make it -3 to 4 of just ak. So this is a minus 3 plus a minus 2 plus a minus 1 plus a0 plus a1 plus a2 plus a3 plus a4. And I want to rewrite this as the sum is L goes from 0 to not 0. Well, yeah, let's actually say from 0 to something. And then I have A, and I have some kind of a blank here that I need to fill in. Well, how do I do this? Well, at this particular point, I'm going to focus in on this idea here. I want to have a -3 when L is equal to 0. So I want -3 is equal to L being equal to 0 plus something. So let me actually say L is equal to 0 plus that something. Well, that simply says that the constant here is going to be -3. So I'm going to look at L minus 3. Now, this is now a matter of getting up to here, and what I want to notice is that 4 will be equal to, well, let's see, 4 will be equal to L minus 3. That's for my ending value. That would say 7 has to be L. So I have to let L go all the way up to 7. And when I look at this particular sum and I plug things in, I want to notice that I really will get the sum is going to start at a minus 3, and then it'll go to a minus 2 and a minus 1, then a0, and then a1, a2, and a3, and a4, and we're going to stop at a4 because at that point we will have reached L is equal to 7. And I just want to kind of count. This is L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3, L is equal to 4, L is equal to 5, L is equal to 6, and L is equal to 7. So we can change counters with just a little bit of algebra, and we can either simplify the subscript on our term, or we can change the counter so that our counter goes from where we want to start it to wherever its natural ending point would be.